This is Professor Derek Seitz. Graphs, real number line. How can we visualize numeric quantities? They can be big and small, infinite and infinitesimal. They need to be measured, ordered, and compared. Here's a picture of pebbles of various sizes and colors lined up by the results of rainwater runoff. Real number line concepts. Each real number represents a signed, positive or negative, quantity. Each real number has a position or location on the real number line. A real number can be visualized as a small point at its position. Numbers to the left have a smaller quantity than those to the right. The real number line is a one-dimensional world, 1D. For this reason, it is sometimes referred to as R1. Here we have the real number line, a horizontally oriented axis called the real axis, or sometimes the x-axis. 0 has to be established, as well as 1. As soon as you establish 0 and 1, that defines the unit, what 1 represents. 2, of course, is twice 1. All the numbers go out here. Negatives to the left, smaller to the left, larger to the right, and this real number line extends infinitely far in both directions towards positive infinity on the right and negative infinity on the left. It's an ordering of all the real numbers. Some examples of real numbers are shown here. 1/4, a fraction. The irrational numbers e and pi. 2 and its opposite, -2. Concept of absolute value comes into note here. Absolute value of a number is its distance from 0, and distance is always positive. The absolute value is indicated by 2 vertical bars around the quantity. The absolute value of 2 is 2 because the distance of 2 from 0 is 2 units. The absolute value of -2 is also 2 because distance is positive. It's the same distance from 0 that 2 is. And the absolute value of 0 is 0. It has no distance from itself. Equations bring questions. Most simple equations in R1 bring simple answers. The solution of 2x plus 5 equals 7 is 1. If you substitute 1 for x, 2 times 1 is 2, plus 5 is 7 equals 7. It is a solution. The solution of 3x minus 4 equals 0. Add 4 to both sides, divide by 3, is 4/3. The solutions, plural, of x squared equal 9 are negative the square root of 9 and positive the square root of 9, -3 and 3. If you square either one of those, you get 9. 2 solutions. However, in a limited 1D world, some equations bring questions. Consider the equation x squared equals -9. The solutions following the example for x squared equals 9 appear to be negative and positive the square root of -9. But what is the square root of -9 in this R1 world. In this one-dimensional world, there is no concept of the square root of a negative number. Such a number, when multiplied by itself to square it, would need to result in a negative product. However, if you take any number, whether it's negative, -3 times -3 is a positive 9, or whether it's positive, +3 times itself is a positive 9, you don't get a negative. It's not surprising that in a limited world, a one-dimensional world, that there are indications of other things that are foreign to this world. Inequalities bring segmentation. The solutions of inequalities in R1 result in answers that involve disjoint segments, also known as intervals. The solution to this simple inequality x is greater than 3 is an open-ended interval, excluding 3, which extends towards positive infinity. The solution to x is less than or equal to 3 is a closed-ended interval, including 3 itself, because of the less than or equal to, which extends towards negative infinity. The solution to this three-part inequality here, where x needs to be greater than -3 and less than or equal to +3, is an interval open on the left and closed on the right. Intervals. Segments. It's important in mathematics to be able to succinctly have symbols that represent intervals, and here is the notation used for intervals. The parentheses indicate an open end on an interval, excluding that endpoint, and the square brackets a closed end on the interval, including the endpoint. There's 4 cases here: open, open, closed, closed, open, closed, and closed, open. Taking this one here as an example, the meaning of this is the set of all real numbers R, the vertical bar means such that R is strictly greater than A, that's why there's a parenthesis there, excluding A, and less than or equal to B, the square bracket. An example of an interval that's open and closed is this one, -infinity to -3. Anytime you have infinity as an endpoint of an interval, you always use a parenthesis because you cannot include infinity, it's unbounded. And the meaning of this, third row here, is the real numbers that are less than or equal to -3. That's the example. There's an alternate text notation if you're writing in text that you can use for some of these symbols. This less than or equal to can be written like a less than followed by equal to. Computer programming languages use these symbols here, or greater than and an equal to next to each other can be used to indicate greater than or equal to, and a double zero with no other numbers attached to it looks like an infinity and is a convenient alternate symbol in text for infinity. And of course, you can put a minus or a plus in front of it. There are some formulas related to the real number line, some basic formulas. One is the distance formula. The distance between two real numbers, A and B, is the absolute value of their difference, A minus B. Some examples. The distance between 2 and 6 is the absolute value of 2 minus 6. That's the absolute value of -4 or 4. And if you switch the order, it doesn't matter. 6 minus 2, 4, you still get 4. The midpoint formula, to find the midpoint equal distance between two other real number points, you add them, A plus B, and divide by 2. Example, a midpoint between 5 and 10 5 plus 10 divided by 2 is 15 divided by 2, 7.5. And the midpoint between -5 and +5, -5 plus 5 divided by 2 is 0 divided by 2. 0 divided by anything is 0.